everyone, and welcome to another edition of Let's Talk ETC. I have Dionysius with me today, who is a PhD student at the University of Athens in cryptography and blockchain technologies. He's also the co-founder of OpenBazaar. Yes, that is correct. The co-founder of the OpenBazaar. And he's also does work for IOHK, Input Output Hong Kong. So welcome, Dionysius.
Thank you for having me.
So there is all kinds of great stuff in your resume that we could talk about. So, but before I do that, why don't you kind of elaborate more in anything that I missed and flesh out kind of more of your background?
All right. So, yeah, it's nice to be on the show. So let me introduce a little bit myself. I mean, you said most of the things. So my current position is at the University of Athens, where I'm a PhD student. I'm honored to work under my advisor, Aggelos Kayas, who is based at the University of Edinburgh. And together we're working on mostly provable security of blockchains right now. And my research is mostly focused on sidechains and interoperability problems between blockchains, whether this is about proof of work or proof of stake. As you said, I'm one of the co-founders of OpenBazaar. My involvement right now is not with the OB1 company so much as with the OpenBazaar community, and also doing some more theoretical research on that. So I'm hoping we can touch on these topics as the podcast evolves.
And how did, going back before, how did you get interested in cryptography and in blockchains initially?
I guess my first exposure to cryptography and security and the cryptography community was when I was interning as a security software engineer at Twitter in San Francisco, where I met a lot of great people who had studied in universities around Silicon Valley, such as Berkeley, Stanford, and some of them held PhDs in cryptography and security, and that kind of piqued my interest. I discussed with them their previous work at their university and so on. And I remember I was having this thought, oh, maybe I want to become myself involved in this nice community of cryptographers and figure out and learn about this fascinating topic. And I asked one of my colleagues, should I do a PhD? And he said, no way. And then I asked him more questions about, why would you say that? And then he said, there is no, if you have to ask that, you should do it. But if you want to study a topic in real depth, then you know it in your heart you want to do it. There's no other reason to do it. So that's when I decided maybe it is for me, and I looked a bit more into it. So that was one of my first moments where I said, maybe I want to become part of this community. Yeah.
So you met some very intelligent, interesting people that when you did work with Twitter. Didn't you also do work with Google?
Yes, that's right. So when I finished my internship, I came back to Greece to receive my master's degree in electrical and computer engineering. And soon after, I moved to Zurich to work at Google for a position as a software engineer, again in a security team. So both my positions at Twitter and Google were software engineer in security. At Google we did. I was in the incident response team, so it was a lot more about actively protecting the network of Google itself, the corporate network, finding out what's happening when there is a breach and so on, and mostly like building tools for the people, for the analysts that were doing forensic investigations about what happened. So,
right. So did you get the free meals that Google is famous for? And did you have the 20% time that you got to play around?
So the free meals are definitely great. I guess in Zurich, there's 3 restaurants inside the Google building you can choose from. There's Mediterranean with pizza and pasta. There's the European with nice Swiss meat, and then there's also the Asian, which often has really good sushi. So yeah, that's true. As for the 20% time, I did get the 20% time, and everybody does. Unfortunately, Google made it really, really difficult for me to work on projects related to cryptocurrencies, including OpenBazaar. So at the time, I applied to work for OpenBazaar in my 20% time as an open source project, like many people do. But Google was really very negative about that, and that was one of the main reasons why I left, and I decided I want to involve myself in this revolution. And the place at Google is probably not the place I want to be in order to be able to do that.
Oh, now see, that's interesting. So Google, why do you have any sense of why they were not interested in people working on cryptocurrency and decentralized technologies?
So I think initially when I emailed one of the open source managers at Google, he was really, really negative about involving myself in cryptocurrencies. In fact, like he said something like, quote, if you want to do that in your free time, feel free to do so, but not at 20% time. And if we find any publication with your name associated with Google, consider your job at stake. So it was very, very heavily worded. And I guess the main worry was that there could be a publication that would associate Google with dark markets, drugs, guns, and so on. It was still in some of the early days where, it was definitely before the frenzy of last year about the price. And it was also at the time where most people had heard of Bitcoin around the context of darknet markets. So I think that was the main worry.
Oh, do you think part of it may have also been that, right, people in the blockchain space talk about Web3, creating a new internet, and the vision of a new decentralized internet, I mean, that goes against their centralized vision of the world, right, where everybody connects into Google.
Mm-hmm.
That was my first thought, that the Web3, the new internet, decentralized peer-to-peer system, that's as if an Apple employee suggests doing something on Microsoft Windows. It's just kind of opposite, that was my thought.
That's an interesting perspective. And actually, when I was spending some time in Mountain View with Google, I went to one of so Google has these nice Friday meetings where they do an all hands, where the leaders of the company will share information and let people ask questions. So one of the questions I asked there to Larry Page was, there's so many people here in Google that are having this huge interest in cryptocurrencies. They're contributing, not just me. I mean, there was Mike Hearn, for example, who had just quit before I started. Why, given that all these smart people show this interest and want to contribute there, and Google's making them leave, why aren't we looking as a company into these technologies, since there must be something there? And what he said was, I'm not aware that we're being so negative, but we have a very small team that's looking into it. And in general, the answer was kind of avoiding the question, I guess. But this kind of hints at the fact that Google wasn't really worried about the space, and I think they still aren't. I think they consider themselves a big player, which is too hard to displace with decentralized technologies, so they're not too worried about that. Personally, I think definitely the decentralized space will eventually spawn up new technologies, including decentralized search, decentralized social networking, and this might mature enough to become prevalent. It's a possibility, but I don't think Google is taking that too seriously.
I see. Okay, interesting. Now, I definitely also want to ask you about OpenBazaar. I've been aware of OpenBazaar for a long time, but I never had the opportunity to ask anybody about it. So it's a anonymous, decentralized market space, right? A marketplace that nobody can shut down or control, and it uses cryptocurrency as part of the tool set. And so, can you kind of talk about the success of that, and how the reception to the idea of OpenBazaar?
Right. So Open Bazaar was my master thesis when I graduated from the Athens Polytechnic. Of course, I didn't do it alone. There's three co-founders who contributed tremendously. So the story behind Open Bazaar is that before I even started my master thesis, a guy called Amir Taki started a project over weekend called The Dark Market. And I mean, I didn't know Amir at the time. He's a good friend of mine now, but at the time, I just found out this project that he was making after I had this idea that, you know, we have all these markets that are centralized, from Amazon and eBay to dark markets like I don't know, the Silk Road, and there's a central operator who can censor transactions. And if it's an anonymous market, they can just stand up and leave and close down their shop and take everybody's money with them. So this literally happened to many dark markets, right? So do we want to have a central eBay that charges fees and is able to censor products at the level of trade? And that's when I thought, you know, we need to decentralize the ability to trade. And this is interesting because Bitcoin now allows us to do that. And then after I had these thoughts and I documented them, I figured out that Amir had started working on this project in parallel with me. Initially, I called my project Agora, and there is this quite long email I sent to this mailing list where I described the technology and the architecture that I want to use. And I had, it's called the Liberation Technology mailing list. It's kind of a more, I guess, a more political rendition of the Cypherpunks mailing list. It's from Stanford. It's really nice. So yeah, I reached out to people from there, and many people were super interested in this. And at the time, Brian Hoffman, one of the Open Bazaar co-founders and the leader of the project, took Amir's code and forked it, and he renamed it to Open Bazaar. And he worked very heavily on it for several months and just recreated the whole thing, really. And he also recruited Sam Patterson, another one of the co-founders, who would manage the community of Open Bazaar and define a lot of the vision. And Sam, he was aware of my work because of that email to Liberation Technology. And he reached out to me and he said, you know, Denisis, you're working on that. We're working on Open Bazaar. How about we join forces, because we have this common purpose and we're both open source projects and so on. So that was great of him. And I got to meet him. We video conferenced a few times, and we said we will join forces. So I abandoned my own attempt and then basically merged some of the ideas that I had there with their code base and started contributing there. So that's how it happened. And that's also when Dr. Washington Sanchez was involved, who's doing a lot of the theory on the contracts that are executed on Open Bazaar. And soon after that, we also met in person with the co-founding team at the FOSDEM conference in Brussels. So that's the story, yeah.
Yeah. Okay. Yeah. And then one question I wanted to make sure not to forget to ask you. So we both are familiar with Silk Road, and the FBI shut them down because they weren't too happy with what was being transacted. Now, I was curious, right, if people sell things on Open Bazaar that governments don't like, have you had that? Has Open Bazaar had that experience yet, where they took some heat and people tried to shut them down?
Right. So that's a great question. So Open Bazaar currently has a lot of goods that are legal and accepted in general. And this is when we created the first version, this was also one of our goals. We wanted to say that, look, a market that is uncensorable and it's impossible to shut down is useful for a lot more things than illegal things and than things that governments want to censor. It's great, because you have zero fees. It's great because you can set up your own store. You don't depend on a corporation and so on, right? So our first attempt was to encourage legal goods. And the first version of Open Bazaar was just over ClearNet with your own IP, being shown to everyone else. So it was more like BitTorrent rather than Tor. And that encouraged the market to evolve into having more legal goods. Nowadays, there's some goods that are illegal being sold on Open Bazaar, including some drugs. Definitely, governments would be interested in shutting it down, but it's not really possible to shut it down in the same way that it's impossible to shut down Bitcoin. All you can do is you can go to the particular store that's running the illegal store and shut them down if they disclose their identity, or if you're able to find their identity. In the same way that a government can go to a miner of Bitcoin to ask them, for example, to shut down their Bitcoin production. So the market itself is not really possible to shut down by a government, but individual stores can be attacked by the government or subpoenaed, of course.
So could the government do like a denial of service attack on as many nodes as they could discover?
Yeah, so that would potentially be possible. As far as I know, we haven't analyzed the denial of service attacks on the network as much as I'd like. So there is some resilience due to the underlying protocols that are being used, but we haven't really played any large-scale simulation scenarios where a denial of service attack could potentially bring down the whole network. I would hope that the network would become a little bit more resilient than what it is today. And the primary way of doing that would be to simulate full attacks and see how the network responds. Right. But the situation is similar to Bitcoin or Ethereum Classic in that sense that, the government could potentially deny service your wallet or many people wallets and nodes or full nodes or miners and try to take them out of the network. But as these liberation technologies have shown us, it's often very hard to shut down people from the internet when they can have alternative connections, when they connect to the network over resilient networks like Tor, or when they even use mesh networks of their own technology and not going over ISPs. So in these cases, there is some underlying technology that can be used to even the most the most adversarial cases, I would say.
No, I think Open Bazaar is important because of what you said. It's similar to Bitcoin and Ethereum Classic technology. So the way that Open Bazaar is received and if it survives and how governments react to it, I think that that's a good indication of what people in Ethereum Classic may expect.
Yeah. So actually, that's a great point because digging through the source code of Bitcoin Core in the early days, one commit I found by Satoshi Nakamoto actually was containing a lot of code in C++ that was trying to create the idea of Open Bazaar within Bitcoin itself. So he had this patch where he wanted to put in the Bitcoin wallet all this ability to search for goods and buy goods from the wallet itself. But I think he discovered that this endeavor was too ambitious, and there's this literally this commit that you can find on GitHub where he just erases this market code and he says something like, I decide that this is not going to be a market, it's just going to be a coin, and then people can build on top of that. So this is very much according to the original vision.
Interesting. Yeah, I didn't know that. So let's get into now that we learned a little bit about you, let's talk about your research work and so you are involved with decentralized trust. Can you introduce us to that?
Right. So that's a really interesting topic. And I would say it's one of the central questions that the community needs to solve. And by that, I mean the decentralization community and the blockchain community in general. It's kind of a central question to every kind of thing we're trying to build in decentralized technologies. And the question is, when you interact with a node on the internet that you don't really know, who is anonymous to you, for example, over some anonymizing network like Tor, where your counterparty is really not accountable to the traditional legal system, you cannot really subpoena them, you cannot really find out their name and take them to court. How do you prevent your transactions from being scammed, let's say, or any kind of interaction, how do you prevent scams? How do you prevent fraudulent transactions, right? How do you really trust some guy on the internet that you don't know who it is? That's a question there. And blockchain technologies in general are a first answer to that, because in the case of Ethereum Classic and other proof of work blockchains, what you do is, in order to fend against some attacker that tries to create multiple identities on the network and pretend that they agree on something, it uses proof of work to take a vote based on computational power. So in that way, you cannot have really one party which pretends to be 1,000 parties and then have 1,000 votes instead of one. So if you think of a different system, if you think of, let's say, you think of Amazon or you think of eBay, the way that trust is conveyed in these systems is you have this eBay listing, let's say, you have this eBay vendor, people buy from this eBay vendor, and then once enough people buy, let's say you have 1,000 people that are buying from them, they leave star-based reviews. And then, if everybody gives them a 5 out of 5 and a good review, then they're trustworthy. But this system is really not very sound if you think about it for a little bit, because the vendor can literally just create 1,000 accounts of their own with 1,000 different email addresses and 1,000 different IPs. And if they're somewhat skilled in computer networks, this is not too hard to automate. And then they can buy from themselves, get their money, from their own account to themselves, leave the 5-star ratings, and then they have an account that has 1,000 or 1 million positive ratings that can basically scam you. And the way that eBay and Amazon and Google and Facebook try to fend off these kinds of attacks is just some proprietary kind of technology where they do some heuristics that are not really cryptographically secure. So they would do things like, ask for your phone number, talk to the phone company, check your IP address, check if you're over Tor, and so on. But all of these, let's say, machine learning based fraud detection mechanisms can definitely be bypassed by an adversary who knows what the mechanisms are. So it's not really a cryptographically secure system. On the other hand, if we talk about a system like OpenBazaar, which by the way currently is based on stars, this star-based system is not really that resilient to an attacker trying to recreate ratings, right? And one difference is that in case of eBay, at least when you buy a good, you have to pay a fee to eBay itself. Right. But in the case of OpenBazaar, because it's a decentralized system, there is no owner, there are no fees. So this attack of creating multiple identities would be basically trivial. And the same holds for a system like Bitcoin. If Bitcoin was just creating blocks by counting how many IPs vote for a block, right, that would be completely stupid, because people would be able to change their IP and take another vote and then perform a 51% attack trivially. But Bitcoin is resilient to that just exactly because of proof of work. So this is why the question of identity is really central to these kinds of technologies. So in my work, we have invented a system with my co-author, Orpheas Litos, and it's a system we call Trust is Risk, in which...
So just so that I'm following you, and so the audience is following you. So from what you said, if I understand correctly, one of the issues in the field of decentralized trust is trying to make a secure reputation system.
Exactly. This is an equivalent way of saying it. A decentralized trust system, a decentralized reputation system, a decentralized identity system tries to create identities and trust and reputation without the vouching of, let's say, governments who issue you a passport, right? We want to do it in a completely decentralized way, in a community way that is not attackable by a court or a government.
Okay.
Right.
And so to get a decentralized reputation system, you were talking about a proof by something. What was it?
Yeah, so we have something called Trust is Risk.
Oh, Trust is Risk. Okay.
Yeah, so this is an invention that we came up with. It was like, I think 2 years ago. in a conference called Financial Crypto in Malta, where we presented for the first time. And since then, we have evolved it quite a bit. This research was funded by OpenBazaar itself and OB1 Foundation, or the OB1 Corporation, as well as FrostWire, which is a peer-to-peer BitTorrent client. And what we did there was we tried to solve this problem for the particular case of OpenBazaar, where you just try to purchase a good and you're not sure if the vendor is really trustworthy, and they will send you that promised good. The way that we approach this is, I mean, it's quite a novel idea, and it's maybe not something that people would be used to. It's a bit controversial, I would say. We introduced a new form of a Bitcoin wallet, where instead of keeping your own money in a wallet that you control, what you do is you choose some trustworthy friends, and then you basically split your money up into lines of credit that you extend to your friends. So if you have, let's say, 10 Bitcoins, you can choose 10 friends that each of them shares an account with you, where you put 1 Bitcoin in. And these lines of credit, essentially, you ask your friend not to take that money. So this is a provable way to illustrate that you trust your friends on the blockchain, and they can use that transaction where you pay to that shared account as proof that you trust them. So implementation-wise, it's just a one of two multi-sig in which any of the two parties can spend. And now that you have this, does that make sense?
Yes.
Right.
So that is so that establishes that you trust some people. I was trying to see the connection between how that establishes a reputation.
Right. So the way you do it is, now if you want to buy something, so these kind of trust relationships, they form a graph where you have people that are connected by trust lines of credit, but of course these lines of credit are between Bitcoin addresses, essentially. Right. So they are anonymous except for your own little chunk of the network. However, suppose now that you find some vendor that you don't really know or trust directly like that. However, you are able to find some sort of path on this network which extends the line of credit from you to a friend, and then from that friend to another friend, eventually arriving at that vendor. Then you can deduce that this vendor has indirectly been entrusted with your money, because you trust your money to your friend, and then your friend trusts their money to another friend, and then that friend eventually trusts that vendor. So if that vendor were to steal that money, take it and go away, then that risk could backfire back to you and cause you to lose money. And observe that you haven't even transacted with that person yet. You've just entrusted money to your friends that you already know are trustworthy, and you have already exposed yourself to a risk that is very calculated, but that risk is to a person that is unknown to you. And that risk we can calculate it. We can put a value on it. We can say, you trust this anonymous person by 2.5 Bitcoin. And now that we have a value on that, we can tell you exactly how much you should be able to trust that person with in your transaction. And the argument here is that when you transact with that person, we give you an allowance essentially on the OpenBazaar interface that says, this vendor is trustworthy up to 2.5 Bitcoin. And now when it's time to spend that Bitcoin and send it to them, what you do is you take out the money that you trusted to a friend that is connecting you to that person, and you're giving it to the vendor directly. Or essentially you're just allowing them to take that money. But the property that we give is not that you will not be defrauded. We will not assure you of that. But the property we give you is that the risk that you willingly expose yourself to by trusting your friends is exactly the same prior to the trade and after the trade. So you can take your own decision by trusting your friends, but we give you a calculation about how much to trust strangers. And that gives a reputation for every vendor on the network, but that reputation is monetary and it's assigned a value, and it's also different for everyone. So I see a different trust for that vendor, and you see a different trust for that vendor, depending on your network.
Right. Now, I'm not very familiar with the the PKI systems and like
Mhm.
the new privacy guard. But I remember there's something called the Web of Trust. So
Correct.
this reminds me of the Web of Trust.
Right. So that's right. Yeah, it's very comparable, and that's a good call. This is actually a web of trust, but it has a few nice extra properties, and these properties are, I would say, there's two important differences between the GPG web of trust and our system. So the first property is the transitivity property. That essentially, in case of GPG, if I sign a key of another party in the PKI, and that party signs the key of another party, and so on, then my signature does not really transfer to, 3 hops away. My signature just vouches for the identity of the first person in the list, but then that person, I can maybe even vouch for their veracity in their signatures, but it goes at most 2 hops away. And this is a topic that is implemented even in the code of GPG, where they say, we only allow up to 2 hops exactly. In our case, where we talk about money being risked, this risk can be argued that it carries from you to the vendor, regardless of how many hops you go through. And this is actually a theorem that we have in one of our papers, which is the trust transitivity theorem. So this is one of the differences with a web of trust. This is the transitivity of trust. And the second major difference would be that in the case of GPG, the edges that you create, or the vouching for other keys that you create, typically you just say, okay, I vouch for this key. But some people also use the functionality where they state how much they put a value on it. So they can say, I trust this key fully, or I trust this key ultimately, or I trust this key partially. But the amount that they trust someone is really the subjective opinion of each person. And the way that each person signs other keys is very different. So for instance, a lot of people go to key signing parties, they just look at government issued IDs, and if they see a name and a face that matches on the photo, then they will put a signature on that. My GPG key, I'm very cautious about it. I don't ask for government ID because I don't want to make my web of trust rely on government censorship or fraud. But I only sign people that I've worked with and I know their name in real life, and I trust the name that they're telling me. So if I put a signature, it's one of my close associates. So me and another person who's giving a signature has a very different value, but this is not conveyed in the network. However, in the trust is risk network, because every edge is literally an amount in Bitcoin, then everybody speaks the same units. My 5 Bitcoin are the same as your 5 Bitcoin. This is a fungible currency, hopefully. So that's exactly the reason why you can see the network and take financial decisions that are quantified in money about transacting with a vendor.
So I can see how this relates to your interest in OpenBazaar. And so this is really just a way to advance, to improve decentralized, commercial applications. So,
yes.
Yeah, so that has huge potential, definitely.
Yeah, and I think actually it has a lot more applications than just OpenBazaar. One small application that we are discussing and working on with my collaborator is the ability to use this to support piracy, essentially. So the exchange of music and videos for free without the interference of big conglomerates. That the problem essentially that BitTorrent or Gnutella could have. And here the one way to address one way that these companies would censor content that is being exchanged there is that they would post spammy content. They would post a song or a video that has the correct title but has junk in it. But if you have such a network the way that we do, you can essentially vouch for the veracity of the content that is being exchanged with you, and therefore you can essentially have a view of the network that shuts out these adversarial entities.
Oh, see now that you've just greatly expanded the scope. So your reputation system could not only work to establish trust in people, but it could also establish trust in digital goods.
Exactly. And it can extend to, it can extend to a lot of things. One other thing would be, okay, remember those reviews from eBay and Amazon? We couldn't tell if they're legitimate, but now if we have this kind of system where it puts a score on everyone, now even the reviews themselves can be sorted based on your view of the network. So it could go highest trust according to your view, comment first, right? Or another application would be if we want to build a decentralized search network that is not Google or not DuckDuckGo. Well, the main problem is spammy content, and if we make the algorithm open source, can people game the system to put their site first? Well, if the site is vouched for by a person that puts it up, then even if you don't know that person, we can assign a score to that person, and then the content that you see can be sorted based on the score of the people that contributed that content. So we can deliver quality content in even search applications. And even if you don't like something like that, you can downvote it, and this can update in a dynamic way your trust network, so that the content that you see changes based on what you upvote and what you downvote. So you can see that this kind of mechanism, if it's designed to work successfully, it can stand in the heart of systems that are decentralized commerce, decentralized search, decentralized social networking, and so on.
Oh, can I give you my suggestion on how you could make $1 million then?
Okay.
Okay, so we both agree that reputation is useful for people, for goods, for reviews, product reviews. So why don't you make a reputation system, maybe with a smart contract on ETC or something, and then make some very user-friendly reputation system that now companies, service providers could then use, and everybody would uses your reputation system, and you could dominate the world with it.
Right. I mean, that's the plan with our research, except we don't really want to own that. We don't really want to charge for it. So there's no way I could make $1 million for that, because hopefully there's going to be no owner of that, not even me, not even the researchers, because I don't want to be able to touch that. It's going to be a system that has its own autonomy. And that's, I mean, the goal here. If it stands in the heart of all these decentralized systems, we don't want a party, who can be forced by the government to shut down this system.
Right. So I guess the way that, I mean, if 1 million, 100 million, billion people used your system, you would indirectly get reputation points, which would probably translate into financial rewards, right? Putting that on your resume. So
yeah, who knows? Yeah, I would be very proud if we could pull this off and have it stand in the heart of decentralized systems. I think it would be a permanent contribution to humankind. So that's a good reward.
Oh, and then also another on your description of what you're working on, they mentioned provable security of the consensus layer. Can
right.
you share that, what you're doing there?
Right. So here we use cryptographic methods to try to describe blockchain protocols. And this was an endeavor that was started by my advisor, Aggelos Kayas, in a paper that came out around, I think, 2013, 2014, which is called the Bitcoin Backbone Protocol. And it's co-authored by Juan Garay and Nikos Leonardos. And this paper is the first, by the way, I'm not a contributor to that paper, but it's an amazing piece of work. I would say it's the most important research written after Satoshi Nakamoto's paper. And this paper really proves the security of proof-of-work blockchains. It argues about basic properties that they have, such as, for instance, that if you wait for 6 confirmations, that's sufficient to have a certain very, very low probability of an adversary double spending. And this is really articulated in that paper and proven secure. And unlike Nakamoto's paper, the paper has a very powerful statement that says, regardless of what the adversary does, your system is going to be secure. It doesn't matter what kind of strategy the adversary follows. It's impossible to break this system. And here's how it's, here's the theorem that proves that, right? So they have a mathematical proof. So they laid the foundations for this mathematical theory that we can use to argue about blockchains. And on top of that, my work is based on that paper, and we are developing sidechains essentially on top of that, and we are trying to argue which protocols that allow interoperability between blockchains really do maintain the same level of security that a sole blockchain would have. So if you make a transaction within Ethereum Classic, that's a secure transaction, we know that. But if we allow interoperability between Ethereum Classic and, let's say, Ethereum, or Ethereum Classic and, let's say, Bitcoin, are these transactions secure? And do they have the same level of trustlessness, or do they need a federation? So that's the kind of question that I'm trying to answer. And that is essentially my PhD thesis.
Yeah, I mean, I can see how that's useful, because that's come up a lot of times on this show, that the future will probably be a future with multiple blockchains and bridges between blockchains. And so, and that we also, a lot of people are excited about side chains. So being able to maintain the security, right, is definitely an important topic to think about.
Yes, and actually being able to maintain the security is really not a simple question of asking, oh, is this X construction secure? It's really more about designing a new construction that will satisfy all the security properties. Because if you try to design construction intuitively, it seems that this is very difficult. And you cannot, in retrospect, prove a construction secure. You have to design it with security in mind from first principles. And so the question of security is really the question of how do we move money between blockchains.
Mm-hmm. Okay. Now, before anybody gets the wrong idea, when you said that it was proved that blockchains like Bitcoin are secure, now I'm sure people are familiar with 51% attacks. So there are ways to successfully attack proof of work based blockchain systems. So you're not claiming that that's not something to be concerned about, are you?
Definitely not. So that's the correct approach here. These papers state very carefully the assumptions under which the security properties are maintained. And one of the central assumptions that is articulated in these papers is the honest majority assumption. So in the Bitcoin backbone paper, the assumption under which all these theorems are proven is that the majority of the computational power is honest.
I see. Okay. And so is that's a reasonable assumption. And so what you're saying is, with those reasonable assumptions, then we can be assured that blockchain technology based on proof of work consensus is secure.
Correct. Yes.
Okay. Oh, okay. Yes, very good. So I think we've covered I think the audience has learned has a good idea of what you're working on and your background. And so, did I forget anything, or is there anything else that you want to add?
Right. So I just want to elaborate a little bit more on the sidechains side of things, which is actually the work I've been doing over the past couple of years. So I think this is really interesting for the audience, because one of the chains that we're building this for is Ethereum Classic. Actually, we are currently building the only bridge that we're building right now is connecting Bitcoin Cash with Ethereum Classic. So this is a bridge that we decided to build because Bitcoin Cash has quite low fees, and the testnet is easy to work with. And then on the other hand, Ethereum Classic, the Ethereum Classic community has been very welcome in allowing us to discuss the potential for new precompiled smart contracts. And generally, they've been very responsive in our ideas. So the way that what we're trying to do right now is we're trying to allow Ethereum Classic smart contracts to be able to react to events in the Bitcoin Cash blockchain. So essentially, in an Ethereum Classic smart contract, what we hope after this work has been deployed, what we hope is in the Solidity code, you will literally be able to reference the Bitcoin Cash blockchain and talk about the existence of a transaction, the existence of a block, the depth under which a transaction has been buried, and all these other nice things, or even the balance of an account and so on. Of course, Bitcoin Cash is UTXO based, so you would have to reference UTXOs there. But then this opens the possibility for some really nice applications, and I just want to mention one. So this one application, we call it the remote ICO. And the idea here is that if you're an investor that holds Bitcoin Cash for an investment, and then you want to buy an ICO token on Ethereum Classic, which is running an ICO sale, instead of using Ethereum Classic units to buy it, you can use Bitcoin Cash units to buy it. And the way that would work is you would deposit Bitcoin Cash into the Bitcoin Cash account of the ICO runner, and then you would post into the Ethereum Classic smart contract a proof that you did that deposit, and then that smart contract would verify in this cross-chain manner that everything is okay and checks out without the need for a federation or a central party that just puts a signature. It's a cross-chain verification that is completely decentralized.
Okay. Oh, so this is an example of a bridge between blockchains.
Exactly. And hopefully in the future, these bridges can be bidirectional as well.
Okay. All right. Very nice. Well, thank you, Dionysius, for talking with us. And for the audience, I would definitely recommend you pay attention to Dionysius. I think he'll be very important in the future of blockchains. He sounds very intelligent. So,
thank you so much for having me, Christian, and for your kind words.
All right. Thanks. All right. So take care.
Bye.